Hi, my name is Tichwa, and today I will be giving a presentation on TDD, BDD, and why each of them are best suited to different situations. Firstly, we must understand what TDD and BDD are. TDD stands for Test-Driven Development, and BDD stands for Behavior-Driven Development. They are two different software development approaches that share a focus on testing and collaboration. We are already familiar with TDD and the red-green refactor loop. Let me quickly recap it before diving into BDD and into comparing the two methodologies. TDD is meant to be continuous and iterative, with the goal of ensuring code correctness and assuring developers that changes to existing code will not break functionality. In TDD, developers will write automated test cases for functionality that does not yet exist, run the test to watch it fail, write the smallest amount of code possible to make the test pass, then refactor code to remove duplication and clean up code smells. TDD is fairly well known among developers, yet many developers I have worked with scorn the practice. Why bother writing a test I know will fail? Why not write the functionality first, then write the test once the functionality is finished? If I give you 10 seconds, can you come up with a few reasons why writing tests first might be beneficial to a software developer? Firstly, confirmation bias is an insidious danger for testing. If you write a test having just finished writing functional code, you're more likely to write tests that pass for the code you just wrote, instead of writing tests that pass only for the functionality you're building. Writing a test and watching it fail guarantees that the functionality is not already present within the code. When working on unfamiliar code, this gives us assurance that what we are building needs to be built. If you write a test expecting it to fail and it passes, something has gone very wrong. The realities of software development often mean code construction can run long, and developers trying to meet a deadline will often write floppy tests in the interest of closing their story on time. TDD prevents that by making sure strong tests are being written the whole time. The red-green refactor loop ensures that you're not writing unnecessary code by encouraging developers to write the least amount of code possible to make a test pass. Oftentimes, developers get caught up in how they think something should be implemented, without considering whether that worry is a priority at the time. By breaking development into small chunks of writing failing tests, making those tests pass, and refactoring code, developers are able to focus only on the tests they are working on, and not be overwhelmed trying to think about every test case they need to make pass. And by having tests already written and passing, developers are not worried about breaking existing functionality. These are only a few reasons why TDD has become so popular, and why developers are often pushed to adopt it. We have already seen TDD in action at this point in the course, so I'll keep this example brief. Let's say we want to write a method to add two integers together called addIntegers. In TDD, we would begin by writing a test case addIntegerSuccess. We reassert that the result of adding 2 and 2 makes 4. We would run this test, verify that it fails, then write addIntegers in a way that makes this test pass. We run the test again and watch it pass. Then we write another statement asserting 3 plus 3 equals 6. We would run this test and watch it fail, because we only wrote addIntegers to pass one test case. We would change addIntegers to make it pass both test cases. Then we would refactor addIntegers to remove redundant code, and run the test cases again to make sure our refactoring didn't break our tests. Now that we've refreshed our understanding of TDD for this presentation, let's talk about BDD. Behavior-driven development is an agile testing methodology centered on system behavior and user requirements, with the goal of ensuring software meets the customer's acceptance criteria. In BDD, the developer is not creating tests alone. They are working with test engineers, product owners, and other business stakeholders to create concrete examples of expected system behavior. Once the examples have been created and agreed upon by all stakeholders, developers will translate these examples into automated tests that will guide the developer as they develop code. BDD does not strictly require that tests be run and verified to fail prior to code development, but for all reasons listed earlier, it is recommended to implement BDD in a red-green factor loop, the same way as TDD. The BDD process starts with an agile team defining the expected behavior of the software. Since this process involves business stakeholders as well as developers, specifications at this point should use natural language. This ensures that the non-technical members of the team can read the test and verify it follows the exact behavior customers are expecting. The language used for these tests is known as Gherkin. In Gherkin, software behaviors are expressed at the highest level as features, such as login or shopping wish list. Features contain scenarios which describe specific situations for the feature, like unauthorized login or successfully added to wish lists. Scenarios are further divided into steps, which are usually a sequence of given, when, then clauses. Given steps describe pre-state, such as given I log in as this user, or given I have an item in my wish list. When describes how the software is first invoked, such as when I hit the landing page, or when I remove an item from my wish list. Then describes the expected behavior of the software, such as then I should see my home page, or then the item should be removed from my wish list. In this example, the customer wants to show the news page on the home page when they log in. We divide that into given I log in as a user, when I am directed to my home page, then I should see my news feed. Gherkin documents are stored in text files with a .feature extension within the application in order to facilitate the next step in the BDD process. Once all the needed features have been written in Gherkin, the developer will convert them into executable tests. The most well-known tool for this conversion is known as Cucumber, available in most mainstream programming languages. Cucumber will read specifications from .feature files and execute automated tests to confirm that the software accomplishes those specifications. It executes these tests by following step definitions written by the developer. Each step will correspond to a step definition method that will execute the behavior described in the step. Given step definitions will set up test data. When step definitions will call the service, and then step definitions will assert that the expected behavior has occurred. The test will fail, and the developer will then write code to make the test pass and refactor code to keep the software clean. Now that we've seen TDD and BDD in action, take 5 seconds to think about what makes these two practices different. BDD and TDD are not truly different approaches. BDD extends TDD and turns it from a developer's process of writing functional code to a team effort to ensure software behavior. When you practice BDD, you should also be practicing TDD. Both methodologies are test-first approaches to software development with a focus on preventing bugs by having a robust test suite. The only difference between TDD and BDD is the scope and collaboration. In test-driven development, the developer can write all test cases alone, and they are focused on testing small chunks of software in a vacuum. In behavior-driven development, many people are working together to define how the end user should see the functional software, without a thought as to how that software is implemented. I found this Venn diagram online that perfectly encapsulates what separates the two methodologies. I particularly like the last bullet points, because I feel they get to the heart of what differs TDD from BDD. Test-driven development is about building the thing right, writing tests to drive development to make sure the software we have constructed is correctly built. Behavior-driven development is about building the right thing, prioritizing the constructed software behaving in the ways customers desire. Now that we understand what makes TDD and BDD similar and what makes them different, it's not hard to see what situations each might be better suited for. TDD, where a single developer writes tests to verify code correctness, is best used for verifying implementation. I test my software on every level, from service invocation to data retrieval and storage. I don't have to pull my team in, and I get feedback on the code I've written instantly. BDD, where a team works together to define expected system behavior, is best suited for verifying service functionality. The team will be secure in the knowledge that the software being delivered meets all business requirements. I hope I have spread some knowledge about TDD, BDD, and the ways in which both methodologies are useful to any team hoping to deliver robust functional code. TDD is a popular process that is still being underestimated by many developers today, while BDD is a lesser-known process that is gaining traction and is being implemented more and more every day. Thank you for attending my presentation, and I hope you have a good day.